All right, welcome. So this is day 3 of the unit 2. This is number 2 of the notes. This is on page 15. So when you start looking at this chart at the top, this looks rather confusing. Multiplicity, so up here, as you can kind of see in the dark gray, multiplicity just means how many times it repeats. There are certain things to a graph that you can determine without knowing the equation. When you see, so I'm going to just go over here to a separate sheet of paper. When you see a graph go down, and it doesn't matter where, but when you see a bounce off, this is like a bounce. When it bounces off the x-axis, I know that's what's called a repeating zero. And it doesn't matter if it, so we talked about yesterday with the left-hand side or the right-hand side, that when they both go up, this is a even degree, and it has a repeating zero. So the number of zeros, whether they're real or imaginary, should total up to your degree. And knowing that this degree is like this, as even, we can determine if it's a 2, if it's a 4, and that sort of stuff. Whereas same kind of graph like this, I know this is an even degree again, so both graphs are even degrees, but on this one I'm going to have the same answer. So let's just say this is 2, so I'm going to have a repeating 0 at 2, whereas this one would be like a even degree again, they're both are up, where I would have like a -3 and a +2, so I would have different values for the intercepts or the zeros. And this happens with every single graph, whether it's like that or upside down. If the graph goes like that, it's upside down, I know the A is negative because it's upside down. The degree is even because they're both going the same direction. So I should say even. I know here, this is my 0 is, but it's repeating because it bounces off the x-axis. And I also know because there's only one turn, that the degree minus 1 is equal to the number of possible turns in the graph. So when you get to something a little bit with odds, this is what essentially the chart is talking about. So it's talking about, so this is degree 1, so odd degree, a degree 3, so another odd degree, and then we go into some even degrees. So these two on the top are odd degrees, so first power and the third power. The root, or the 0, is at x equals -3, and this is x equals 1. But because this happens 3 times, the repeating exponent of 3, this is what's referred to as multiplicity of 3, or repeating 0. So the repeating 0 keeps happening, so it happens 3 times. So when we start looking at odd degree graphs, one side is going to be up, one side's down. And the more it repeats, the flatter it goes through the x-axis. So there's the repeating 0 of 1. And when it goes up, instead of being like a straight line, so it happens one time, it starts getting more flat and more flat. So something with like x minus 3 to the 5th, well, it happens at +3. The graph, when you get here, would be even more flat for a while and then go up. So when you see the repeating 0, ultimately what happens is it gets kind of flat around the x-axis, or it bounces off for the next 2. So when you see these 2 degrees, so even degree of 2 and even degree of 4. So x plus 2 occurs 4 times. So x squared happens twice, so x and x. Okay, so 0 is a repeats 2 times, so multiplicity of 2. Or x plus 2, the x value is at -2. And that's multiplicity of 4. And that's when it bounces off the x-axis. That's what I first talked about. When it comes from even degree, both up and up, and it bounces. Or when it gets more and more, it's going to be more closer to looking like it's flatter on the x-axis, or sitting kind of there. All right, so when I look at graphs, and one side's up, one side's down, I know what the graph should do based on how many times it repeats at that number. So we're going to do some graphs starting next week, where you're going to have some more multiplicity, and then we're going to be able to figure out where they bounce or where they are flat and that sort of stuff. All right, so for the rest of today, I'm working on a polynomial function of degree 3. That means you should have x to the third as your biggest exponent. And the zeros are 4, 2, and -1. So if the zeros are 4, 2, -1, this means x equals 4, x equals 0, x equals -1, or as an ordered pair, it'd be on the x-axis at 4, 2, and -1. So with that in mind, excuse me. First it asks you into factored form, so really it's just looking for these, you're going backwards. Okay, so taking these values, what you'd want to do is move the number back over here so it equals 0. So I would subtract 4 from both sides. I would subtract 2 from both sides. I would add 1 to both sides. Alright, so I have x minus 4 equals 0. I have x minus 2 equals 0. I have x plus 1 equals 0. And when you do that, these values are your factors. So it's x minus 4, x minus 2, and x plus 1. So really it's essentially, yes, it is like taking the opposite, moving it over and saying, if it equals to 4, the factor is x minus 4. So these individual parentheses are factors. Okay, so the whole parenthesis is a factor. Now when it says standard form, this just means multiply it out. That's it. So multiply it out. So if you have x minus 4 times x minus 2 times x plus 1, this means ultimately just FOIL it out. Or distribute, so those two. Plus 8. Okay, so take 2 at a time. I chose to do x minus 4, x minus 2. Do those two together, or another set, and then multiply it finally with the last one, because recall that it said it has to have a degree 3. Right now I have a squared here, and so I know I'm not done. So this goes to both, so I have x cubed plus x squared. That one goes to both. Minus 6x squared minus 6x plus 8x and plus 8. So combine like terms, I end up with what? X cubed minus 5x squared plus 2x plus 8. Alright, so this last one here for today. So these are in factors. So I want to set each one equal to 0. Okay, so set each factor equal to 0, so I get x equals positive 1, x equals positive 3, x equals negative 2. But there is something to keep in mind, because it's repeated, I would have a second x plus 2, so I would have a repeated 0 at negative 2. So when you look at this, here's my total. Because I have 1, 2, 3, 4, or if you look at the parentheses, I have 1, 2, 3, 4 here. This is a degree 4, so it's even. So then I know the graph should be even. I have zeros at 1, 3, and negative 2. So negative 2 is repeating. 1 and 3. So they're either going to be both up or both down, so left-hand side, right-hand side. So now I got to think about it. So I have this negative in the front. I got to be careful. So if I did negative times negative times negative, so I'm just kidding. Sorry, I have a negative here times positive 1x times positive 1x times positive 1x. I would ultimately end up with a negative a value. So the a value is ultimately negative, so everything is going to be upside down. Now I got to keep in mind that if it's a degree 4, it's going to have number of turns is going to be the degree subtract 1, so that's going to be 3 turns. But I have a repeating 0 here, so that means it's going to bounce. So without having a graphing calculator, it's going to be facing down up to negative 2 and it bounces, so that's 1 turn. Somewhere in here it's going to turn around again. When it happens only one time, it goes through the x-axis and then turns around again, and it goes through the x-axis again to finish going down. So all this has to fit. Number of turns is 3. I got 1, 2, 3 turns. I have degree 4, so they're both down, or both going the same direction, and a value is negative, so they're both down. Everything has to fit together. All right, thanks. We'll talk to you soon. Bye.